So a scientific notation, it's really an application of all those exponent rules we just talked about. And so if I did, I guess I should summarize what scientific notation really is to begin with. A lot of times in application, in your the reason it's called scientific notation, in your science courses or in the fields of science like physics and chemistry and biology, you deal with numbers that are either really, really big or really, really small. You can see this in finance too, in business, and in other applications, but it typically tends to show up in physics, astronomy, chemistry, when you're dealing with things at the microscopic level or things at the universal level, right? Huge things. And so we don't often want to write out all of the digits of numbers that are huge. So if I wanted to figure out or if I was talking about the distance across, or the distance between two galaxies in space, and talking about the number of miles, that's enormous. It's like I don't know, it's a huge number that I would never want to write out. I would never want to have to do any calculations with. And so we have a notation to sort of shrink those down and make them more compact and usable. Same thing with things that are really, really tiny. Like if you're looking at the mass of an electron or something, that amount is so small if you're measuring it in grams, for instance, that there's so many zeros after the decimal, and then you finally get to a number that's not a zero, and then you've got a few numbers down there. And so rather than having to sit there and write out and count out all your zeros after the decimal, it's easier to use a different notation instead. And so we'll talk about that. And it all comes down to the exponent rules that I had up here previously. So a couple just general principles is that when you multiply by 10 to a number, you add a 0, right? So if I had 372 multiplied by 10, you just add a 0 to that, and it's 3,720. Okay? And if I were to multiply by a different power of 10, so if I were to multiply by a different power of 10, like 100, I'm just adding 2 zeros. Oh, that's not what I want to write. If I were to, right there. If I were to multiply by a different power, like 100, then I add 2 zeros to the end. And if I multiply by 10,000, that's 4 zeros. I need to have 4 zeros tacked on, right? And so the number of zeros in that power of 10 is the number of zeros tacked on at the end of the number. Okay, so that being said, these powers of 10 can be written more succinctly without writing out all of the zeros, but instead using an exponent to represent the number of zeros, right? So like 10 times 10 times 10 times 10, 4 of them is 10,000, which has 4 zeros. So the number of zeros is represented by the power on the 10. Okay? So if I needed to write out a number that had like 20 zeros, like if it was 1, 2, 5, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I don't know how many that is. I just made a bunch of them. So I'm going to group them in groups of 3 to count them, right? 3, 6, 9, 12, 15 zeros. So that would be 125 times 10 to the 15th, right? So those 15 zeros give me 15 power. Now this is not true scientific notation, because true scientific notation does have a power of 10, but it has the initial number here has to have a decimal in it. Only has a ones place, so it'd be like 1.25. So imagine moving the decimal from the end all the way over here. It takes 15 moves to get it between the 5 and the 0, but it takes 2 more to get it over to the 1. So to make this true scientific notation, I would want it to be 1.25 times 10 to the 17th. Okay. Oh, I missed my 10. Times 10 to the 17th. Okay. So 1.25 times 10 to the 17th. So, and again, if you were to take that decimal then and move it 17 places to the right, you would get the number I initially had up there. Okay. So that's scientific notation. Clearly, this number on the right is way easier to write and deal with than this top number with all the zeros, having to count them all out and keep track of everything. If I wanted to multiply or divide this number to some other stuff, it's a lot easier to work with these powers than it is to deal with all those zeros. I got a couple things coming in. Exactly. Yeah, it's a lot of zeros. Okay, so that's how to make the numbers bigger. So basically, really big numbers are represented by positive powers on your 10. However, now, if I were dealing with really small numbers, okay, so like I said, the mass of an electron or something like that, that's going to we're going to be working with negative powers on the 10. And the reason they're negative powers is because you're really dividing by 10 instead of multiplying. And remember, when those powers are on the bottom, they're negative. So if I were dealing with the number 4.8 times 10 to the minus 8, then this is really a smaller number. It's a number quite a bit smaller than 4.8 because I'm multiplying by 10 to the minus 8. Remember, 10 to the minus 8 is really the same as dividing by 10 to the 8th, okay, or dividing by a 1 with 8 zeros. So we don't, instead of writing all that out, we could move the decimal to put it back into standard form. So I'm going to put the 4 and the 8 over on the right because I know I need a bunch of a decimal with a bunch of zeros in here. So I start with the decimal between the 4 and the 8, and I want to move it 8 times to the left. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. That's where I would end. And in each of those little bumps, I'm going to fill in with a 0. All right, so there's a 0, 0, 0, 0, 0, 0, 0, then a decimal, and then another 0 up front. Okay. So with a negative 8 there, I have 1, 2, 3, 4, 5, 6, 7 zeros, and then a decimal, and then another 0. Okay. That's typically going to be the case. The number of zeros between the decimal and your first digit will be 1 less than the power. So the power is negative 8. There's going to be 7 zeros in there. And again, this is quite a small number, right? If I wanted to rewrite 0.000000513 in scientific notation, this is a small number, so it's going to have a negative power on the 10. And I want to write it as 5.13. Remember, I want to have a ones place and then a couple decimals times 10 to a negative power, and the power will be equal to the number of places I move that decimal. So it's 1, 2, 3, 4, 5, 6, 7 places. So I want a negative 7 in the power. Okay. Okay. I don't know if you guys have any other questions on that. Pretty short section. That's really all it is just converting these things to and from scientific notation. So your calculator does work with scientific notation. If you were to punch in your calculator a couple really big numbers and multiply them, for instance, if you did something like, I don't know, 458722103 times 9987996 or something like that. If you were to type that into your calculator real quick, if you have it with you, or I'll do it here just to show you what's going to happen. 458722103 times 998796. I'll pop this on the video there. So what you'll see is this a really long decimal followed by an E13. Okay, so let me write that up here. What you're getting is 4.58168729 E13. Well, what ends up happening is your calculator uses scientific notation, but it doesn't write it in the same form. This E stands for exponent or exponential. And so what you're dealing with here is times 10 to the 13th power. So this part of the expression really means times 10 to the 13th. So the actual, and I probably wouldn't write out all of these digits. In application, if you were actually doing this for a reason, like working with, in astronomy, or if you're working with, I don't know, in engineering, in an actual example, you might want all the decimals, or you might need a certain number of decimals for a certain accuracy. I would probably just round it off after the hundredths place. Your textbook, or not your textbook, my math lab will tell you where to round these off, or it should. So just be aware of that in the instructions. Usually in parentheses at the end, it'll say round answer to the nearest hundredth or something like that. So or the 2 decimal places. It'll tell you. It usually tells you where to round them if there's any question. So here I'd probably do something like 4.58 times 10 to the 13th. And so this is the answer that my math lab will accept. This is the answer I would accept rather than the E. This is just what your calculator gives you. Okay, so just be aware of that. The calculator is using scientific notation, but it's writing it out differently than what I would have you do here with the powers. Okay.